Okay, so 1, 4 is based on, we're working with parametric equations. So you can graph parametric equations on your calculator. You just need to change the mode. So your calculators stay in function mode by default. If you click the mode button, which is right here, and you scroll down to where you see function or FUNC, go to the right, and then PAR is short for parametric. Yeah, the one that says calculus. Now if you do that, once you hit enter, when you hit the Y equals button where you normally enter in your functions, that will allow you to put in your parametric equations. So for like problem number 4, now we're still gonna have to do some algebra to kind of, you know, convert parametric equations to Cartesian equations, but sometimes it's nice to see the graph. So if we were to do problem number 4, it says x is equal to 12 times sine of t.
How did you get the x in there? You go to mode.
Go to mode and hit parametric equations. And then, so it was 12 sine of t. Oh wow, that's a complicated one.
Where do you get the t?
The X button automatically switches to T when you're in parametric mode. Okay? Minus 3 sine of T. Oh, 3 sine of 6T. 6T. I think that's right. And then your Y values are based on the following: 12 cosine of T plus 3 6t. 3 cosine of 6t. Alright, so double check, make sure I've entered everything correctly. And so just to read the example, it says, match the parametric equation with their graph, state the approximate dimensions for your viewing window, give the parametric or parameter interval that traces the curve exactly once. So now here's the change. So first let's graph it. Okay, so I'm going to hit graph, and it doesn't quite fit. So you could do zoom fit. So if I go to zoom, and I think it's option number 9, 8 or 9. Oh, 0. And then you hit enter, it'll fit it. Now here's the thing, the parametric equations draw these really cool patterns, but we want to figure out exactly where it stops. Otherwise it'll just keep drawing forever. Now since we have sine and cosine, and those are what we call periodic functions, they will repeat at certain intervals. So what do you think would be a good, and we don't call it, we call it an interval, but it's kind of like a domain. What are some good values for t that we could plug in? 0 to what?
0 to, and then 2 pi, 3 pi over 2.
Yeah, something like that. 0 to 2 pi would be good, because that would be one full period. So here's where you enter it in. Are you guys ready? Watch this. If you go to window, now it looks completely different. And notice that Mr. Adams already has it set up from 0 to 2 pi. Now you can enter in pi or 2 pi or however you want to do it just by entering in the pi sign. So if I hit second, and the pi symbol is right above the caret key. So you hit second caret, and now I'm going from 0 to pi. Okay? And so if I'm going to go from 0 to pi, and when I hit graph, it only goes halfway. Do you see that? So what do you think our interval for t should be? 2 pi. That's what it was. So I just wanted to show you that. I had the right answer. I had it entered in correctly, but I just wanted to show you. So what I could do is I could go to window again, and here I would say 2 times pi. And then your calculator will automatically convert it to the decimal. Okay? So then if you hit graph, then it'll go in. And so then the answer, the question for number 4 is, so number 4 says, if you write it out of the textbook, number 4 asks you, it gives you the parametric function of 12 sine of t minus 3 sine of 6t, and y is equal to 12 cosine of t plus 3 cosine of 6t. This is another reason why we do parametric stuff. This is really difficult to do in Cartesian equations. In fact, you'd have to have multiple equations. So, well, no, I shouldn't say it that way. It'd be very difficult. It'd be very difficult. Well, this one's actually one of the simpler ones. But you could see that there's complex patterns that you could do a little easier with parametric equations. So now what does the window interval have to be? So if we talk about the window settings to get it to fit, if you do zoom fit, what did we do for our window? Well, if you go to window again and you scroll down a little bit, when you did the zoom fit, it actually went from negative 14.5 to a positive 14 for the x, and for the y it's a similar thing. So I would say something like negative 15 to positive 15, and then negative 15 to positive 15. Okay? And you would say by. Now this is the confusing part. This looks the same. This is the same set interval notation, right, that we use for other things. This doesn't mean we're going to go to the point negative 15 comma 15. What we're really saying is that these are the x values, the min and max, and these are the y's. Okay? And then the other thing is, what is our interval for t? So we would say that t can be between 0 and 2 pi. So this is technically the answer. You got to use your calculator to get it, but that's technically the answer. Yeah. Let me stop that.